Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers circle theorems. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 8. A, B, C and D are points on the circumference of a circle centre O. Angle CAD equals 280 degrees and CD equals 6.4 centimetres. BD is the diameter of the circle. Calculate the area of the circle. Okay, now in order to work out the area of this circle, we're going to have to know its radius then, aren't we? Because the area of a circle is pi r squared. Okay, so pi we know, r is what is required in order to work this out, isn't it? So do we know any distances? We know this distance here, CD. Okay, how does that help us? Well, firstly, let's use some of our circle theorem knowledge. We've got an angle here, 28 degrees, which is being subtended from the chord CD, isn't it? So you can see that that angle is coming out of that chord CD. Now this angle up here is also being subtended from that same chord, which means that that angle there must also be 28 degrees. Okay, so just get rid of that green. So that angle there must be 28 degrees as well. Okay. The other angle the other circle theorem we can use is the fact that we've got a diameter here, BOD, and we've got an angle subtended from it, which is CD plus the line BC, which means that this angle up here then must be a right angle there, mustn't it? Because the angle drawn in a semicircle is a right angle. Okay, so that is quite helpful because that means we've got a right angled triangle which we know one angle of and one side of. So let me just pull that out. So I've got B, C, D, B, C, D, where that's a right angle and that is 6.4 degrees. Now I want to find the radius or the diameter, which is the line B, half of BD, isn't it? So if I can find this side here, I should be good. Okay, remember that is 28. Okay, so using a bit of trigonometry, let's label up the sides. That long side, the yellow side there, is the hypotenuse then, isn't it? And 6.4 is going to be the opposite. And my other side that I don't really care or know about is the adjacent. What I care about is the hypotenuse, and I know the opposite. So which ratio is that then? Write down our mnemonic, SOHCAHTOA. I don't know how you remember this. I just tend to write it down like that. Which one has got to do with the hypotenuse and the opposite? It's this one here, sine. So let me write that down then. Sine of my angle is equal to the opposite over the hypotenuse. So subbing in from my diagram, sine 28 is equal to opposite 6.4 divided by BD then, isn't it? The length BD. Okay, just going to call it BD. Okay, rearranging, BD then is equal to 6.4 divided by sine 28, and then that is equal to what? 6.4 divided by sine 28 apparently that is 13.6. And that's going to be the diameter of my circle then, isn't it, BOD? But we want the radius for our calculation. So what's that, OD or BO? I think we'll call it OD. OD is going to be 13.6 over 2, which just divide my calculator divided by 2 is about 6.8, isn't it? Okay. Okay, so now I know the radius, I can work out the area of the circle. So coming back to my formula from before, area of the circle is pi r squared, which is pi times 6.8 squared. Now I've written down 6.8, but I'm just going to use the whole calculator value that I've got just to retain accuracy. So I'm going to take my 6.8, my answer from my previous calculation, I'm going to square it, and I'm going to times it by pi. And that comes out to be 145.959, which I'm going to round up. I'm going to make that 146. So that is equal to 146 centimeters squared. There we go. Question 9. The dimension. Question 12a. Points A, B, and C lie on the circumference of a circle. EAF is a tangent to the circle. Write down the values of B, C, A, giving you a reason for your answer. Okay, so where's B, C, A? Well, here's B, there's C, there's A. So B, C, A, B, C, A. We need to find this angle here. Okay, sorry, the diagram got a bit mangled when it got printed out. So you've got angles there, 53, 78 and 49. Okay, on the line there. They're all like angles on a straight line, should add up to 180. Okay, now we want that angle there. Now I know straight away what it is because I know my alternate segment theorem. So this angle here is going to be the same as this one using the alternate segment theorem, isn't it? So I know straight away what that is, that angle BCA is going to be 53 degrees, and because of the alternate segment theorem. Part B says point G, H and J lie on the circumference of a circle, centre O. Angle GOJ is 52. Angle GJH is X. Lines JO and GH are parallel. Find the value of X. You must show your working. Okay, so all that information I was just checking is already on the diagram. GOJ is 52 is marked here. Angle GJH is equal to X. That's there, look. And we've got the two parallel lines marked. Lines, they're parallel, they've been marked here, look, and here. Okay, so they're already on the diagram. Now we need to find the value of X. So that angle down there, what's that one? Now, first off, I know that, well, I'm just looking at it and thinking about what I can find. So often these questions, don't focus on the thing that you want to find. Just think about what it is you can find first and then see if you can work it out from there. Okay, so first up, I can see that I've got an angle subtended at the center, which is 52, and an angle subtended at the circumference over here, look. Okay, now these two are not equal. Now normally these ones look more like this. If you watch Star Trek, it's like the Star Trek insignia. So that angle there is twice that one, isn't it? The angle at the center is twice the angle at the circumference. So that means that angle JHG is equal to 52 divided by 2. So that is going to be 26 degrees. And the reason for that is angle at center is twice angle at circumference. Okay, so that's that. Well, so now I know that that one must be 26. So I guess I know this one as well because of parallel lines. When you've got a pair of parallel lines and a line crossing them, then this one and this one are called alternate angles, and they're equal, aren't they? And that's what I've got here. So 52 and OGH are alternate, so that must be 52 as well. Okay, and that's because they're alternate angles. That's my reason. So that one there is 52. And now how does that help me? I guess I want this angle here, don't I? Okay. Now I can find that one because OJ and OG are both radii. So that triangle JOG is an isosceles triangle. So if you think about it, here's O, here's J, and here's G. Now J and G are both on the circumference, so that means that these two are radiuses, so they're both the same. So that means this is an isosceles triangle. And I know that that at the top there is 52, so then that means I can find these two then, can't I? So what angle is that? That's OGJ. So I want angle OGJ, and that is equal to it's going to be 180 minus 52 divided by 2 then, isn't it? So 180 minus 52 over 2. Okay, what's that then? So 180 minus 52, 180 minus 52, and that's 128 to share out between those two bottom angles. That's 64 then, so there must be 64 each. Okay, so that's 64 and that's 64, so that means that's 64 over there. Okay, so now I can work out the angle that I'm looking for. Now I can work out GJH. I can just use the angles in the triangle. So then JGH then, I'm going to use angles that add up to 180. So if I take 180 and I take away the two other angles in the triangle, one of which is 26, and the other which is the combined angle of 64 and 52, isn't it? So 64 plus 52 kind of added together. That's my two angles then, isn't it? If I add those together and take it away from 180, I'll be left with X. Okay, so what's that then? So 26 plus 64 plus 52 comes to 142, and take that away from 180, that's 38 degrees, isn't it? Okay, so JGH is 38, and that's the answer I'm looking for. I'm looking for 38. Okay, so it's quite tricky, that one. You have to kind of work your way around it a little bit. Like I say, I didn't even think about what X was first off. I have just thought about what I could find, and then once you do that, then normally you know, the thing you actually want to look for kind of falls out of the problem eventually. Okay, so don't get hung up too much on the thing you want to find. Just find what you can find and work your way around the diagram until you get to where you need to get to. Question 14. A, B, C, D are 4 points on a circle. SBT is a tangent to the circle. Angle ABD is 20 degrees. The size of angle BAD compared to the size of angle BCD is in the ratio of 3 to 1. Find the size of angle SBA. Give a reason for each stage of your working. Okay, now quite a lot of information written below the diagram. I do like to just go through and double check that everything in the text is on the diagram. So let's just go through that line by line. A, B, C, D are 4 points on the circle. A, B, C, D, there they are. SBT is a tangent to the circle. SBD is T is a tangent to the circle. Yes, it is. Angle ABD is 20 degrees. Angle ABD is 20 degrees. That's there, yes. The size of angle BAD to the size of angle BCD is in the ratio of 3 to 1. So where's BAD? BAD, so that angle there compared to BCD is in the ratio of 3 to 1. So that isn't on there, is it? Okay, let's just get rid of this. So let's just do that a bit more neatly. So comparing this one to this one, so they're in the ratio of 3 to 1. So BAD is 3 for every 1 you've got in BCD. So I'm going to just show that as 3x and x, that one up there is 3 times bigger than the other one. Okay, and we want to find the size of angle SBA. SBA is that angle there. Okay, right, so quite a lot going on this diagram. We've got cyclic quadrilaterals, we've got this alternate segment theorem, and we've got a little bit of algebra that we've introduced because of the ratio. So we've got quite a lot happening that we're going to have to kind of sort our way through. Right, I think what I'm going to do is I'm going to start with the cyclic quadrilateral A, B, C, D, because I looked at it for a little bit and I was trying to work out an in to this question, how I can get started. Okay, because normally it doesn't, you know, I wouldn't massively over focus on the thing that I want to find. I want to find this one over here, but you know, it will come. Okay, like with these harder problems, you've got, you know, lots of things you need to sort out. So I just think, well, what can I find straight away, and then see what I can find from that, and hopefully I'll make my way around to the thing I actually want to find. Okay, so I'm going to start with the cyclic quadrilateral because I know a fact about cyclic quadrilaterals. I know that in a cyclic quadrilateral, then opposite angles sum to 180 degrees. Okay, now the reason I picked on that one is because I know that these two in relation to each other, these are opposite angles in a cyclic quadrilateral, and because I know their size relative to each other, that is enough to work them out, isn't it? Because I can say that, so in ABCD, angle DAB plus angle BCD equals 180. Okay, in other words, 3x plus x is 180. In other words, 4x is 180. So x then is going to be 180 divided by 4. That's 45 degrees. Okay, so once I got that, now I know that this one down here is 45, and this one over here is 3 lots of 45, which is, what's that, 135. Okay, so therefore DAB is 135 degrees, and BCD equals 45 degrees. Okay, so we're making progress. So we now those. So now, if you have a look in triangle ABD, angles in a triangle sum to 180 degrees, don't they? Okay. So I know A is 135, B is 20. So A plus B plus D is going to be 180. So I know that A is 135, B is 20, plus D is 180. So 135 plus 20, that takes me up to 155. So take that away from 180, that's going to leave me with 25 degrees for D then, isn't it? Okay, so angle D there then is 25 degrees. So that one there is 25. Okay, now I think I'm pretty much done here then, because the last thing I want to look at is the alternate segment theorem. So I've got a tangent here, SBT, and I've got a chord drawn at the point of contact going in this direction. And the alternate segment theorem says that the angle between the tangent and the chord is equal to the angle subtended in the alternate segment, which is this one here. It's the 25 degrees. Okay, using alternate segment theorem, then I'm going to say then that angle SBA equals angle ADB equals 25 degrees. Okay, in other words, angle SBA is 25 degrees. 25 degrees. Okay, so that was quite a bit of work to do that. So I used the cyclic quadrilateral first to find those two angles. Once I had those, I could use angle in a triangle to find D, and once I had D, I could find the alternate segment theorem to find SBA. Okay, it worked out in the end. Good, let's move. Question 16a, here is a circle centre O. Work out the size of angle X, and I've got various choices here to pick from. Now you'll see that angle X lies in the centre, and it's subtended from the same 2 points as this angle up here, so it must be twice as big. So it's going to be 2 lots of 52. 2 lots of 52 is 104. So the correct answer is 104. Question 16a. In the diagram, A, B, C are points on the circumference of a circle. O is the centre of the circle. Angle OAB is 15 and angle BCO is 10. Okay, and then we've got the diagram and we're asked to calculate the acute angle AOC. Okay, right, so let's have a look at our diagram. Just my advice is just to always double check this stuff up here and make sure all the information is in the diagram, because sometimes it isn't, but in this case it is. I've got A, B and C clearly marked, O is clearly marked, and these two angles are clearly marked as well, so it's all on the diagram already, but always worth to check because sometimes it isn't. Now calculate the acute angle AOC. So AOC, so the acute angle there is that one there, isn't it? Okay, so we want to know this angle here. How are we going to do that? Okay, so we know various rules on circle theorems that spring to mind. This one here looks, I don't know if you watch Star Trek, looks like a Star Trek badge to me. You've got this one here where you've got angle at the center being twice the angle at the circumference. So if that's x, that one there is 2x. That's one of the rules you need to know. But that's not going to help us totally here because we don't actually know this angle at the top. So in order to find AOC down there, we're going to need to know what this angle is up here. Do we know that one? No. Can we find it? Of course we can. But we're going to need to do a little bit more thinking in order to get there. And I think the easiest way to do it is to add an extra line to your diagram. Now you are allowed to do this. There's no law against you adding an extra law in. I'm not going to get arrested by the line police by putting that extra line in there. And actually it makes this diagram much more clearer because O to B is a radius, as is O to A. So these two things are the same length, aren't they? And actually O to C is, so they're all the same length. They're all radii, so they're all equal to each other. But by adding those lines in, you should see that triangle OBA is isosceles, which means that this angle up here, this bit in there, look, that is also 15 degrees because it's the base angle of an isosceles triangle. Similarly, this part up here is also an angle in a base angle in an isosceles triangle. It's triangle OBC, isn't it? So this angle here is going to be the same as that one up there. So that one is 10 degrees. And that means that angle ABC is going to be those two part angles added together. So angle ABC is going to be 15 plus 10 degrees. It's going to be 25 degrees, isn't it? Okay. And that means that angle AOC, the angle at the center, is going to be twice the angle at the circumference. It's going to be angle ABC times 2, which is going to be 25 times 2. It's going to be 50 degrees. Okay. All right. So that's not too bad. What's the next one say? Right, now first up, this one here says explain at the bottom. So that means we need to give reasons for things, which means that we can't just work out the angle. We need to explain what we're doing as we go through. We have to be a bit more detailed with our working. Okay, let's just read through the question. In the diagram, E, F, and D are points on the circumference of the circle. Yeah, they're all there. GDH lies on a tangent to the circle. Yes, it does. Angle EFD is 55 degrees. That's on there. And angle FDE is 43 degrees. That is on there. Explain why angle HDF is 82 degrees. Where's HDF? HDF is HDF. So we're talking about this angle. Okay, oops. This angle here, that's HDF. I'm not going to write 82 in there because we need to find 82. Okay, if I just write it in there, then I'm not explaining why it's equal to it. So actually, probably what you want to do is cover up this to start with, because that's the fact you're trying to find. Okay, if you write it in the diagram, then you forget that you're actually trying to find it. So I'm going to leave the value out. You can cover that up for now and pretend it's not there. Let's see if we can work out what that angle is. Okay, right, so what have we got in my diagram? We've got a triangle EFD, okay, and we've got two angles in the triangle and one missing. So I can easily find the angle E. I can say that angle E, what's that equal to? That's going to be equal to 180 minus those other two angles then, isn't it? 55 plus 43. 180 minus 55 and 43, that's 98. 180 minus 98, that's going to be 82 degrees, isn't it? Okay, so that is 82 degrees. Okay, and the rule we're using, I'm going to put underneath, next to each thing that I do, we're using angles in a triangle. Sum to 180 degrees. I might just be a little bit clearer and say in triangle EFD to start with. Okay, so in triangle EFD, then E must be 82 because the angles in a triangle summed 180 degrees. Right, now I can use another one of my circle theorems now straight away to find the angle down there that I'm looking for, HDF, because I remember this one here, which is the alternate angle theorem, which says the angle between a tangent and a chord drawn at the line of point of contact is equal to the angle in the alternate segment. In other words, this angle here, the angle between a tangent and a chord drawn at the point of contact, is equal to the angle in the alternate segment. It's this one here. So we can say straight away, actually, now then, so therefore HDF is equal to 82 degrees, and the reason for that is the alternate segment theorem. Okay. So with these explain that questions, don't put that thing in there to start with. That's what you're aiming for. So if you put it in there, you'll just confuse yourself. And explain means that you have to put these reasons in. So if you just work out the angle, then you'll only get half the marks for it. You know, you have to actually show your thought process and the rules that you are applying. Question 16. A, B, C, and D are points on the circumference of a circle centre O. Angle BAD is 112 and angle DCO is 33. Show that the angle Y equals 35. Give reasons for each stage of your working. Okay, so I just always double check, make sure everything in the question is actually in the answer already. So BAD, is that marked? BAD, yep, that's on there. It's 112, look. Is angle DCO marked? 33. DCO, yeah, that's already on there as well. Just always double check that, because if you're missing a piece because it isn't on a diagram but it's in the question, you could stymie yourself. Okay, but it's all there, so we should have all the information we need. Okay, so how are we going to work out y? Now with these complicated looking circle theorems, you've got to find a way of kind of fading out a lot of the information and just look for the shapes that you know. Okay, there are certain rules that you should have in your head about circle theorems, and you need to try and focus or see those in the kind of more complex diagram. So for instance, one of the rules that I know about is cyclic quadrilaterals, and I can see a cyclic quadrilateral in this diagram here. Okay, so if I kind of just fade out all the rest of it and concentrate on that cyclic quadrilateral, then I know that in cyclic quadrilaterals opposite angles sum to 180 degrees. Okay, and I've got this 112 angle here, so I can use that then to find this angle from here to here then, because those two should add up to 180 degrees then, shouldn't they? So that's my first thing I'm going to be using. So I'm going to say in cyclic quadrilateral ABCD, then DAB, that angle up there at the top, plus my angle down here, DCB, equals 180, because opposite angles in a cyclic quadrilateral sum to 180. We know DAB is 112, and so we should then know what DCB is, because I can take that away from 180 and find that DCB is equal to 180 minus 112. That's going to be 68. So DCB is 68. Okay, so but I already know DCO, which is part of that angle, so I can then use it to find the other part of the angle, this angle here, then this angle here, OCB, can't I? Okay, so I can say that DCB is equal to DCO plus OCB. Okay, so that's 68 is equal to DCO, which we already know is 33, plus our angle OCB. So that means that OCB then must be 68 minus 33, which is 35 degrees. Okay, so I know that then this is 35 here, but COB is an isosceles triangle, isn't it? I can say that COB is isosceles. Okay, so therefore the other angle, OBC, is going to be equal to OCB. But the other angle is Y, and OCB I know is 35. So that's 35, so y is 35. Okay. Next step, I need to work out angle Z. Where's Z? Okay, Z is over here. I want to find this one next. Okay, how can I do that? Now again, I'm kind of trying to look for simpler shapes within my kind of complex looking diagram. And I can see that Z is kind of at the tip of one of these shapes here. If you ever watch Star Trek, it's like a Star Trek badge. Maybe you don't watch Star Trek. Anyway, you should know that that tip of a Star Trek badge is always going to be twice that one there then, isn't it? So that one is going to be 2Z, okay, because it's twice as big. And then I should be able to work it out because I know what y is and I know what 35 is. So I can easily find that angle there COB, and then I can halve it to find Z, can't I? So that's my plan of attack. Okay, so I'm going to find Z for that 2Z one. I'm going to work out this one first, and then I'm going to use it to find Z. Okay, so I'm going to say that angle COB is, it's going to be 180 minus 2 lots of 35 then, isn't it? Okay, because my two base angles are 35. So COB is going to be 180 minus 70. It's going to be 110 degrees. And therefore, CDB is going to be 110 divided by 2, which is 55, because angles subtended at circumference are half the angle subtended at the center. Okay, so that's the rule that I'm using. So the trick for circle theorems, as I say, is trying to see those simpler shapes within your more complicated looking diagram. You know, you've got like 4 or 5 of them that you need to be on the lookout for. So you need to kind of focus in on those shapes and ignore everything else, and then you should be all right. Question 16. A, B, C, and D are all points on the circumference of a circle. PQ is a tangent to the circle at D, and angle BDQ is equal to 72, and angle ABD is 63. And we need to work out the angle X and give a reason for our answer. Okay, let's just double check that all the information given in the text is on the diagram. So I've got the points A, B, C, and D. They're all marked on my diagram, aren't they? So that means ABCD is what we call a cyclic quadrilateral then, isn't it? Okay, so this A, B, C, D, and back to A again, is a cyclic quadrilateral. So we've got some circle theorems about that. PQ is a tangent to the circle at D. Okay, so there's my tangent PQ along there. And then angle BDQ is 72. So angle BDQ is that one down there then, isn't it? The 72. And ABD 63 up here is that one. Okay, so that's all on the diagram. Just, it's always worth double checking because sometimes they leave it out. And now we need to find angle X. Okay, so to find angle X, how are we going to do that? Okay, let's just clean this diagram off and start and have a look at it again. So we said that PQ was a tangent. Now notice that there's a line drawn from D up to B, isn't there? So that is a chord drawn at the point of contact with the tangent. And we've got this angle here, which is 72. That's between the tangent and that chord. Okay? Now, the alternate segment theorem says if I subtend an angle from that chord, so here, then that angle there is going to be the same thing as that angle down there. It's called the alternate segment theorem. So that means that angle X is equal to 72, and the reason is because of the alternate segment theorem. Okay? And the second one, I should read Y, it's a typo. So work out the angle Y at the other side of the diagram. Again, I'm going to clean the diagram off here so we can see it a little bit more clearly. But we said that ABCD is a cyclic quadrilateral, and X and Y are opposite angles in a cyclic quadrilateral. Okay, so you should know that opposite angles in a cyclic quadrilateral add up to 180. So X, which we've just worked out, is 72, plus Y is equal to 180, which means y then is going to be 180 subtract 72, which is 108. Okay, so I'm going to say that y is 108 degrees, and the reason for that is they are its opposite x in a cyclic quadrilateral. Question 17. A, B, and C are points on the circle. Center O. BD is a tangent to the circle. OCD is a straight line. Work out the size of angle X. Okay. Now, in order to work this out, I'm going to have to apply various circle theorems to this diagram. Now, first up, I've been told that BD is a tangent to the circle. So that means that this line here, OB, which is a radius drawn at the point of contact, that needs to be at right angles to the tangent, because that is always a thing. So those two lines must always be at a right angle. Okay. Now the second circle theorem that I can use is the fact that the angle at the center is twice the angle at the circumference, like that. So that angle there being 32, if I double it up, then I'm going to get the angle here, which must be 64. Okay, so that angle must be 64. So then I found two angles in this triangle down here then, haven't I? Okay, and I know that the angles in the triangle add up to 180 degrees, and I know the other two, so I should be able to find x. So I should know that x plus my 64 plus the 90, my three angles in the triangle, add up to 180 degrees. So if I add those two together, so that's x plus 154 is equal to 180. So taking 154 away from both sides, then x is going to be 26, then, isn't it? So that's my answer. X is 26 over 160. Question 18. A, B, and C are points in a circle, center O. DC is a tangent to the circle. Show that the ratio of angle ABO to angle ACO is in the ratio of 3 to 1. Okay, well, all sorts of things going on here. So we need to find angle ABO at some point, which is angle ABO is this angle here between these two. So it's going to be that angle there. We want that angle. Okay, and we want angle ACO. So angle ACO is there, down there, and down there. So we need to know that angle there as well. Okay, so we need to find those two angles, and we need to show that they are in the ratio of 3 to 1. Okay, but how are we going to do that? Okay, well, first off, what do we know? We know this angle up here, 28, and we know this angle down here. Now, I don't really focus too much on what the problem is asking me first off. I just think about, well, what I've been given and what can I find. Okay, so let's take that so that 83 degree angle there on the tangent. Okay, so using the alternate segment theorem, I know that the angle between a tangent and a chord drawn at the point of contact, which is this 83 degree angle here, is going to be the same as the angle subtended in the alternate segment. So if I were to draw two lines coming off of that, then that angle up here, then that's going to be the same as 83. Okay, and that's because of the alternate segment theorem. So that angle there is 83. Okay, so we know that what's that, angle ABC. So angle ABC is equal to 83 degrees, and the reason for that is the alternate segment theorem. Okay, now this is a show that question, so you need to give reasons for your statement. So you can't just find angles, you've got to give reasons as well if you're going to get all these marks. So I know that angle ABC is 83. Okay, what else do I know? I know the angle at the center, don't I? So I can look at that 28 and I can use it to find this angle down here then, because I know that the angle subtended at the center is twice the angle at the circumference. So that tells me then that angle BOC is equal to 2 lots of 28, which is 56 degrees. And the reason for that is angle at center is twice angle at circumference. So for the paper, it's good to memorize these little statements for each of the various rules that you need to know about, because for the show that questions or the proof questions, you do need to justify your reasoning. Okay, so angles at the center is twice the angle at the circumference. So I know that BOC is 56, so I've got that one, it's 56. Okay, and I know that one, it is it's 83, and I know that BOC is an isosceles triangle, isn't it? Because OB and OC, they are both radii. Okay, so that is a radius and that is a radius, so they're both equal in length. So I can say triangle BOC is isosceles. Okay, so therefore angle OBC, so angle OBC is going to be equal to angle OCB. Okay, those two base angles then, like there and there, are going to be equal to each other, aren't they? And they are going to be 180 minus the angle at the top, minus the 56, divided by 2. Okay, so I'm taking the 56 away from 180, and then I'm sharing what's left between those two base angles. So 180 minus 56, what's that then? That's 124, and divided by 2, that's 62 degrees then, isn't it? Okay, so that one is 62 and that one is 62. Okay, so I'm feeling like we can now at least find one of our angles. We can find ABO then, can't we? Because I know that ABC is 83, and I know that BOC is 62. So if I take one away from the other, it's going to leave me with ABO. Okay, so angle ABO, which is one of the ones I wanted to find, that's going to be angle ABC, which I already found, minus angle OBC, which I just found. Okay, so that is going to be ABC was 83 from up here, look, that was 83, and then OBC, going to take away OBC, which was 62, okay, which we found over here, so that's that one there, so 62 there, look. Okay, or there. Okay, so then that leaves me with what? So ABO then is going to be 83 minus 62. That leaves me with 21 degrees. Okay, so I know that ABO is 21 degrees. So now I need to find ACO. How can I find that then? Well, I guess I know two angles in the triangle ABC now, don't I? I know that the one at A and I know the one at B. So I can use that to find the angle at C then. So let's do that. So in triangle ABC, then I can work out angle at C. I can work out ACB, that angle down there, because I know it's going to be 180 minus the other two that I know. So it's going to be 180 minus ABC, which I've already found, and the other one, which is ABC and BAC, isn't it? Plus BAC. So adding those two angles together. Sorry, that 5 marks was a little bit annoyingly in the middle. So that's going to be 180 minus angle ABC, which was 83, and then angle BAC, which was 28. So if I add those together and take it away from 180, what's that? 83 and 28, that's 103, 111. 111 from 180 makes 69. That's 69 then. So that's 69 degrees. So then I can then work out what ACO is then. So now I can work out ACO. ACO, that's going to be the angle I just found, ACB, minus that angle in the triangle OCB that I found earlier. Okay, so ACB minus OCB, that is going to be ACB we just found to be 69 degrees, and take away OCB that we found earlier, which was 62 degrees, and that leaves us with 7 degrees. Okay, so I now have angle ABO, it's over here, look, it's 21, and I've got angle ACO, found that's 7. So now I can say that ratio of angle ABO to ACO, so ratio ABO to ACO of those angles is going to be 21 to 7, which cancels down to 3 to 1. Okay, so I got the 21 from earlier there, and I've just worked out the 7, and that cancels down to 3 to 1. Question 18. A, B, C, and D are points on the circumference of a circle. EF is the tangent to the circle at D. Angle BDF is 70 degrees. The ratio of angle BCD compared to angle CBD is 5 to 2. Work out the angle CBD. You must show your working. Okay, so just reading through there. A, B, C, and D are points on the circumference of the circle. So A, B, C, D. So if you've got 4 points on the circumference of a circle, do you know what that's called? It's called a cyclic quadrilateral. They have some properties that we might come in handy in a moment. EF is a tangent to the circle at D. Okay, that's also got some useful properties that we're going to come into at the moment. So that's my tangent. And then angle BDF is equal to 70. Okay, right, so what I'm going to do, first off, I'm going to look at this angle down here, this 70 degrees. Now, I did say earlier that, yeah, tangents have properties when they touch circles like this, and one of them is the alternate segment theorem. So, using alternate segment theorem. Now this is a show your working question, so you know you have to put these little nuggets into your answer to show that you know the rules that you're using. It's not good enough just to find the angles, you have to explain the process. So I'm using that rule to find another angle here. Now the alternate segment theorem is one of our circle theorems that we need to know, and that says the angle between a tangent and a chord drawn at the point of contact, which is the 70 degrees that we labelled a second ago, is equal to the angle subtended in the alternate segment, which is basically if you subtend an angle off that chord, which this angle up here is, they're going to be the same. So that 70 degrees there has to be the same as this one here. Okay, so the green line is the tangent. I could say that this pink line here is the chord, and then the angle over there at A is the angle subtended off of that chord. You can see both its feet are at the end of that chord. Okay, so that one over there has to be 70 degrees. Okay, so using the alternate segment theorem, then I can say that angle DAB is equal to angle CDF. And that is equal to 70 degrees, isn't it? Okay, so we've got one part of the puzzle. Okay, now the next thing we're going to be doing, we've got a ratio that we need to use in a bit between BCD and CBD. So BCD, where's that? That's this angle over. Running out of colours. What colour am I going to go for? I might go for pink again. So this angle over here, what's that angle there? Okay, we need to know that one, because once we know that, then we can use it to find CBD. Where's CBD? CBD. We can. It's that one over there then. Once we know that one, we can find that one over there, hopefully. because we got the ratio. Okay. Right. So now I can find that pink one that I first did. I can find this one over here using the fact that ABCD is a cyclic quadrilateral. So I'm going to write that down. ABCD is a cyclic quadrilateral. And what that means is, again, if you look at your circle theorems, in a cyclic quadrilateral, opposite angles sum to 180. So opposite angles sum to 180. In other words, angle DAB plus angle BCD must be equal to 180 degrees. Okay. Now I already know DAB, it's 70. So 70 plus BCD is 180. Okay. So then taking 70 away from both sides, it's going to give me BCD by itself, isn't it? So BCD angle is equal to 110 degrees. Okay, so we now know that that's 110. And then finally, we said we can use this ratio down here that says the ratio of angle BCD to the angle CBD is in the ratio of 5 to 2. Okay, so BCD to CBD angle is in the ratio of 5 to 2. Okay, but we now know that BCD is 110. That's 110 degrees. Now, what do I have to multiply 5 by to get 110? Well, 110 divided by 5, that's 22, isn't it? Aren't I timesing that by 22? Okay, 22 lots of 5 is 110. So, because this is a ratio, do the same to both sides. So if I multiply the other side by 22 also, I'm going to get the size of angle CBD then, isn't it? So that's going to be 2 times 22, that's 44 degrees. Okay, so therefore angle CBD is equal to 44 degrees. All right, we did it. CBD, I found it. Good job. Yeah, so this is a 5-mark question. You're only going to get all the marks if you are clear about the rules as well as finding the angles. Okay. Question 19. A, B, C, D, and E are points on a circle. BFD and AFC are straight lines, and we're told that DC is equal to DF. Now, all that information is already on the diagram, plus we've got a few extra pieces of information. What we need to do is work out the size of angle X, which features here, and it also features again next door here. Okay, so we've got X appearing twice there. Right, so what shapes do we recognize? Well, you should notice that you've got two angles subtended from the same chord, from this chord here. Look, it's one of those bow tie type circle theorems, and with those we know that these angles subtended from the same chord or arc are equal, so that one there must be the same as that one over there, so that one must be 24 as well. So once we know that is 24, then this is an isosceles triangle, so I can find these two angles, can't I? So this one here and the other one, they're going to match, and they're going to be equal to 180 minus the 24 divided by 2. So 180 subtract 24 is 160, 156, and dividing 156 by 2 gives me 78. So that is 78 degrees. So I've got two 78s, so I've got a 78 there and a 78 here. Okay. Now, we were told earlier that AFC is a straight line. So we can use the fact that those three angles must sum to 180. So we know that x plus 2x plus my 78 degrees is equal to 180 degrees. So collecting like terms, 3x is going to be 180 subtract 78. 180 subtract 78 is 102, and 102 divided by 3 is 34. So x is equal to 34 degrees. Question 21a. A and B are points on a circle. PA and PB are tangents. Work out the size of angle APB. Now, if PA and PB are both tangents, that means that these two lengths have to be the same. It's just a property of tangents that meet at a point outside of circle. So those two are going to be the same, which makes triangle APB is isosceles then, isn't it? Isosceles, and therefore that angle there is also 71 degrees. What are we trying to find? APB. APB. We're trying to find this angle here then, aren't we? Okay. So this angle up here is the vertex of your isosceles triangle. So we already know the other two is 71, and we know that the angles of a triangle add up to 180 degrees. So APB, the angle at P then, plus my other two angles are going to be 180. So 71 and 71 makes 142. 142 away from 180. What's that then? That's 38 then, isn't it? So it's going to be 38 degrees. 21b, C, D, and E are points on a different circle. Is X the center of the circle? Tick a box. Show working for your answer. Okay. Now, if X is the center of this circle, then this is that kind of Star Trek circle theorem that we need to know. It looks like the Star Trek badge. That's always the way I think about it. I don't know if you like Star Trek or not. But anyway, that rule says that the angle subtended at the center, this angle here, is twice the angle subtended at the circumference. Okay, so if X is the center, then the angle X is going to be two lots of the angle at subtended at the circumference, CED. CED is 78, so that would make X 156. Okay, is that consistent with the other angle? Angles at a point sum to 360 degrees. So if those two angles added together give us 360, then it all kind of works out, doesn't it? So 156 plus 204, what does that equal to? That equals to 360. Okay, so it does work. Okay, so I'm going to say yes, because X is the center because of what we just argued a second ago. Okay, on to circle theorems. A, B, and C are points on a circle. CD is a tangent to the circle. And we need to write down the size of angle X and give a reason for our answer. Okay, so here's angle X. It's the angle between the tangent and the chord AC. Now, because I know my circle theorems, I've easily spotted that because this is a tangent and this is a chord drawn at the point of contact, and this is an angle subtended off that chord in the alternate segment, then I know that that angle there is the same as my angle X. That's the alternate segment theorem in action. So I can just say that X is 65. So x is 65 degrees, and the reason is the alternate segment theorem. That's just enough. Just writing that down as the reason is good enough. Question 19. The diagram shows a circle center O. Points A, B, C, and D lie on the circumference of the circle. EDF is a tangent to the circle. Angle ABC is equal to 82, and angle ODC, is equal to 57. Okay, I'm just checking through that. Really, all that information is already marked on the diagram. But always do just double check, because sometimes there's extra stuff up here that's not been marked, and if you don't put it on, it's going to make it pretty much impossible for you to answer the question. So just read through it carefully and just double check that everything is on the diagram. But here it is. Okay, right, next up, what do we need to do? We need to work out the value of x. Okay, well, that's pretty easy. Let's have a look at triangle ODC. Can you see triangle ODC? ODC. What sort of triangle is that? Well, if you think OD is, well, O is the center, isn't it? So it's a line going from the center to the edge. That is a radius, isn't it? That's a radius of my circle. But then so is O to C. That's also a radius of my circle. And those radiuses have got to be equal. So that line and that line must be equal in length, which means ODC is an isosceles triangle, isn't it? So that means that the angle there must also be 57. And if that angle is 57 and that angle is 57, if I add those together and take it away from x, from 180, sorry, I should get x. So my three angles, x plus 57 plus 57, must be equal to 180. So adding those two together, 57 plus 57 is 114, and taking that away from 180 then, 180 subtract 114, what does that leave me? 180 subtract 114, 80 subtract 14, 80, 70, 66, isn't it? So x then is 66. Okay, I'm going to add that to the diagram because I think we're going to go on and do some more calculating, aren't we, in this diagram. Next off, we need to work out the value of y. Now, it's not immediately clear how to proceed here, is it? But I've got an unused angle up here. I know that this one is 82, so it's probably got something to do with that. And also, did you notice that A, B, C, and D all lie on the circumference? So we've got here what is called a cyclic quadrilateral, haven't we? So A, B, C, D, and back again. That is a cyclic quadrilateral. Okay, so how does that help me? Well, I know in cyclic quadrilaterals, opposite angles add up to 180. Okay, so if that one over there is 82, then its opposite number, which would be kind of this whole angle down here, so including the 57 and that little bit in the middle there, must be 180 subtract 82. So what would that be? So that's ADC, isn't it? So angle ADC is going to be 180 minus 82, because they're opposite angles in a cyclic quadrilateral. So that makes it, what's that? 180 minus 82, that's 98. Okay. So if that's 98 all the way across there, then what is angle ADO? ADO then is going to be 98 minus 57. So that is 42? 41. So ADO must be 41, so that bit there must be 41 degrees. How does that help me? Are we there yet? Not really. I've got, oh, okay, what else can I do? It would be handy if I knew this one here, wouldn't it? but I don't. If I knew that one, then I know that y, my 41, my 57, and that little angle down there all lie on a straight line. So what's that angle? Now, if I could only find this angle here, we'd be in business now, then, wouldn't I? Because that's the only one I don't know on that straight line. So how can I work out that angle down there? Okay, now my diagram's a little bit crowded now, but you can see that OD is a radius drawn at the point of contact with that tangent. So you should know that radius drawn at the point of contact with a tangent, those two lines are going to be at 90 degrees to each other, then, aren't they? So that angle there between OD and DF is 90 degrees. So angle ODF equals 90 degrees, and the reason for that is the angle between a radius and a tangent is 90. Okay, and if that is the case, then you can see that part of that angle is 57, so the other part of the angle, CDF, so CDF then, that little smidgen down there, in there, that is going to be 90 subtract 57 then, isn't it? Which is going to be 33. Okay, but probably we didn't need to do that, because if I know that that's a right angle, then that's 90 plus the 41. That tells me that y plus the 41 plus the 57 and the 33 that we just found, which we know adds up to 90, all those together lie on a straight line, so that must be equal to 180 degrees. And if that is the case, then y then is going to be 180 minus those three angles then, isn't it? So 57 and 33, you know, adds up to 90, plus the 41 is 131. So 180 subtract 131, what's that? That is equal to 49. 49 and 131 is 180, isn't it? So 49 degrees, and that's my y. Y is 49. Question 22. A, B, and C are points on a circle. DCB is a straight line. PAQ is a tangent to the circle. All that information is already on the diagram. I've got nothing extra to add to it. So Sam is trying to work out the size of angle M. Here is his method, or his working. Angle ACB is 56 degrees. Angles in the same segment are equal. M equals 180 minus 56. Angles at a point on a straight line add up to 180. M is equal to 124. Make a criticism of his working. Okay. Well, how would I work out this? I would note the fact that that angle down there is 56 and use it to work out this angle up here. Now this angle is also going to be 56 because these two angles, this one here and this one here, are equal because of the alternate segment theorem. The angle in the alternate segment is equal to the angle between that chord and the tangent. And then I've got two angles that lie on a straight line, so this angle here plus the 56 is going to be 180. So then M is going to be 180 minus 56 because of angles on a straight line, which gives me 124 degrees. Okay, so I'm agreeing that ACB is 56. I'm agreeing that M is 180 minus 56. And I'm also agreeing that M is equal to 124. So that is all fine. What is not fine, though, is this statement here. Angles in the same segment are equal. Now, that is a true thing. Angles in the same segment are equal, but that's not what we've got here. Here we've got the alternate segment theorem. Angles in the same segment is this rule where you've got two angles drawn off the same chord. That is angles in the same segment being equal. That is not the rule we've got here. So my criticism is, so what's his name? Sam. Sam should have used the alternate segment theorem, which didn't do. Here is a cyclic quadrilateral, and we're told, oh, they're loving these ratios today, x to y is 5 to 7, so work out the angle W. Right, so I've got, what have I got here? I've got two opposite angles in a cyclic quadrilateral that add up to 180 here, so those two add up to 180. So x plus y is equal to 180. So that can give me an equation in x and y. And then down here, I can say then that y equals, what? So if I take x, I divide it by 5 and times it by 7, I'm going to get y. So y is 7x over 5. Then I can turn that into an equation like that. It's very similar to one we had earlier. I'm not sure why this paper is testing the same skill twice, but here we go. So y equals 7x plus 7x over 5, and x plus y is equal to 180. So I can be able to solve these two simultaneously then. Again, I can solve them by substitution. So subbing in that value of y into x. So x plus y, x plus 7x over 5, then is equal to 180. So x plus 7x over 5, x is 5x over 5, so 5x over 5 plus 7x over 5 is 12x over 5. So 12x over 5 is equal to 180. So dividing 180 by 12 will give me 12 into 180 go 15 times, and then times in that by 5. So x equals 180 over 12, which is 15 times 5, which is 5 15s are 75, aren't they? So x is 75. Okay, so now we know that x is 75. That one up there then must be 75 plus 20. It must be 95. And we know that these two are opposite angles in a cyclic quadrilateral, so they must also add up to 180. So W plus 95 must be equal to 180 degrees, making W equal to 75, 85 degrees. Okay, 26 is circle theorems. I have A, B, C, D being points on circumference, O is the center, AC is a diameter of the circle, and AT is a tangent. Okay, so let's take AC first off. If AC is a diameter, then the angle in the semicircle is going to be a right angle, so I've got a right angle there. Now I know that this angle here plus the 72 make up a straight line because I know that AC is a diameter. So that angle there must be 108. Now I don't know if you can see this, but you've got an angle subtended at the center and an angle subtended at the circumference from the same 2 points. So this angle here must be half of that 108, so that must be 54, making this part of the angle, what's left out of the 90 degrees, that bit there is going to have to be 36. Okay, now coming over to our tangent, we've got a tangent here and this angle here is y, then I've got a tangent and a chord drawn at the point of contact, so the angle subtended here, look, that is alternate segment theorem. Using the alternate segment theorem, I can see that that's got to be equal to my y value, so this one here and this one here are equal, so y equals 36 degrees. Okay, now looking at this angle here, now that one is subtended from the same chord as this 30. You can see they're both subtended from this chord along here. So this angle up here is also going to be 30. That's going to be 30 degrees in there. So then using my right angle triangle, I can work out that this one, x, then is going to be 180 minus my 90 degrees minus my 30 degrees. So that makes it 60 degrees. X is 60. So write that below the line, x is 60. So just writing those answers in the box. 60 and 36.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.